Hey guys, welcome back to a new video. In last video we discussed about the oligosaccharides and all that stuff. From today we are starting the polysaccharides, and the first is the starch. First of all, let me tell you this is a polysaccharide. Polysaccharide, that means that it is formed of many saccharide units. Like oligosaccharide, the that was formed of 2 to 10 polysaccharides. In the same way, the the polysaccharide is formed of 10 plus saccharide units, and the starch is one of the example of it. And this is formed by this is a homo homopolysaccharide. This is a homopolysaccharide. You are familiar with these terms, like uh, um, because homo and hetero, and the chemistry also dealing with it. The homo means the same, so same saccharides, no other saccharide, single sort of saccharide. Starch is a saccharide, polysaccharide found with single sort of saccharides, monosaccharides. While there are also other heterosaccharides which are formed by different sort of saccharides combined. Look, we are looking into starch homopolysaccharide. By the upcoming videos, we're looking into the polysaccharides, the heteropolysaccharides as well. So let's get into today's topic. This is the homopolysaccharides. What sort of homopolysaccharides, which is the monomer? So the alpha glucose is the monomer of this alpha glucose. Alpha glucose. Uh, yes, and this is found in a lot of stuff. Remember this: we eat starch. Eat starch. Human, human eat starch. We eat starch in the form of food, and it is one of the important biomolecule. Uh, the starch gets converted into animal starch, that is uh, looking into later on videos. Glycogen, but right now you've got a starch that is present in the plants, present in plants, present present in plants. Right. uh, so uh, this acts as a source of carbohydrate for us, as this is a poly homosaccharide of carbohydrate, and it is present in our food stuff. And the structure of the starch consists of two parts. The first one is starch. The structure starch contains of two parts, number one and number two. And the number one is amylose. Amylose, amylose. And the second one is amylopectin. 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 Right. This is the both constituents, and the amylose is around 15 to 20%. 15 to 20%. That is around 18 to 80 to 85% amylopectin. 80 to 85%. Uh, First of all, I'm making the structures. Uh, the, the amylose has got uh, alpha, sorry, alpha 1 for glycosidic linkage. Between carbohydrates we have got glycosidic linkage, and in amylopectin we have got alpha 1 6. Now you'll be thinking, like, how can we go present? We're just getting into the structure. Alpha 1 6 glycosidic linkage. Okay, so I'm drawing the structure. uh, the, like, amylose is the linear one, linear, and the amylopectin is uh, uh, the upper one, one. And this always comes at upper one at every, see, 25. Every carbon number, every 25 carbon number gap, the amylopectin structure would be present. These are very important points, minimum, very small but very important points. Every 25 number of carbon atom, the amylopectin is present, and amylose is soluble in water while amylopectin is not. And let's get into the structure. For saving your time, I'm just looking into a beautiful picture to deal with it. Let me come back. Okay, so I'm back. Like, see over here, this is one of the beautiful picture that I did found. In this, what is amylose? I was saying that was a linear change of alpha 1 for glycosidic linkage of glucose. This is amylose, simply 1,4 linkage. Uh, this is carbon number 1 of glucose 1, this carbon number 2 of glucose 2. We have learned all this condensation process in our previous videos, like how this the 1,4 link forms and all that, how the glycosidic bonds forms. So you just need to be cleared up with your basis. Do check out my channel. We have got a complete series of biomolecules and to understand all that stuff. And this is how the amylose will form the linear chain. And if you talk about amylopectin, uh, okay, just leave, this is just a bit of confusing stuff for you. I'm just removing it and mentioning other thing over here to make you more clear, because this is not only amylopectin, it also includes uh, the we say this also includes uh, the complete starch molecule. This is the starch molecule, not only amylopectin, starch molecule. And this bond formed is called as amylopectin. Amylopectin, AP I'm writing, and this one the linear, which is amylose. We've just looked into a word. Okay, so so here, if you do see, every carbon number 25, this is carbon number 25, or suppose there would be uh, a bond found between alpha 1 and 6. This is carbon number 6, and this is carbon number 1, and here a bond is formed, and this is called as this one, uh, amylopectin bond. And amylopectin and amylase form a complete molecule, that is starch. Like, this is the linear chain over here, and this is the amylopectin chain, and both have bonds at every, this is a branch structure present. There are not that much branches, but there are on every C25. Okay, so I do hope that you have learned the structure. This was a very wonderful diagram that made the whole concept clear to you guys. Meet you guys in the next video. Till that, goodbye.